All right, welcome to the Ecosystems for PSoC and XMC MCUs webinar with Infineon. We've got Clark Jarvis here with us today to share about PSoC and XMC microcontrollers and 4 software ecosystems that support them: Modus Toolbox Software, Zephyr, MicroPython, and XMC-for-Arduino. So a little bit about our speaker today. Clark is a software and tools technical marketer at Infineon, building on nearly 2 decades of product experience for embedded software and development tools. Clark focuses on creating efficient and intuitive design experiences to help embedded engineers ultimately master and speed the development of IoT and industrial applications. So thanks again for joining us, and I'm going to let Clark take it from here.
All right, Katie, thank you very much, and thank you everybody for joining. As Katie introduced, we're going to go over some of the ecosystems that are enabled for the PSoC and XMC microcontrollers. A little bit more of details on the agenda that I'll cover. So first, do kind of an introduction of PSoC and XMC devices and the ecosystems that we're talking about in this webinar. Then I'll do a specific, little bit more of a deep dive overview into the Modus Toolbox software, as that one's probably one that many of you are probably newer to. We'll do kind of a brief overview of the third-party ecosystems, specifically Zephyr, MicroPython, and then the XMC for Arduino. And each one of those is going to have a little bit of a different flair to it, or a different set of capabilities and support. So we'll go through each one of those and talk about what devices are available, what libraries are available, what type of peripheral supports are available in each of those ecosystems. And then we get down to really the more interesting part of it. We'll go through the actual kind of getting started steps. So this is where we'll have somewhat of a demonstration. This is a short amount of time and a lot to cover, so things are going to be kept at kind of a high level, but we'll make sure that you guys have the links and at least show you that the right places to start so that you can get going with it. This webinar is being done in kind of alignment with the Connect Things with Code Design Challenge that is running right now at Hackster.io. So we'll tie that in, and then after that, we can open it up for any questions you guys have. So a little bit about the microcontrollers that we're going to discuss. And this is a subset of the Infineon's consumer and industrial MCU portfolio. There are other devices, there are other PSoC devices, then going on up to the automotive space. So this is a subset that's really geared around these ecosystems that we're talking about. On the consumer side, we have the PSoC 4 devices with up to 48 megahertz, 384 kilobytes of flash, going up to the PSoC 6, which we bring in dual core capability, 150 megahertz and up to 2 megabytes of flash. On the industrial side, we have the XMC 1000, 48 megahertz, XMC 4000 going up to 144 megahertz, 2 megs of flash, and then a recently released family, the XMC 7000, that brings in the Cortex M7 dual core plus the Cortex M0, so quite a powerful industrial microcontroller, all being supported inside of the various ecosystems, or at least some of the ecosystems that we'll be talking about today. So with regards to those ecosystems, the ones that we're going to cover in this webinar is Modus Toolbox. So this is the development environment, the ecosystem that is kind of formally developed by and supported by Infineon. And so you'll see the largest range of devices supported in that ecosystem. So everything that we showed on the previous page, and actually there's more that are actually included in Modus Toolbox, are available there. If you have been working with PSoC devices or XMC devices in the past, you're probably familiar with other tool chains like the Dave IDE or PSoC Creator. So just I do have a little note down here, and I know we had some questions that were pre-submitted regarding this. Those IDEs and those tools are still available. You can download those and use those from Infineon. We don't anticipate any new releases for those particular products, but they still are available. They're still they still have devices supported inside of them. But Modus Toolbox is intended to be the ecosystem and the set of tools that will replace those, or will, as new devices come out, they will go into Modus Toolbox, and we are actively developing and improving Modus Toolbox to really capture a lot of those features and use cases that were in Dave and PSoC Creator. The other devices we'll talk about are the other ecosystems, Zephyr, which supports the PSoC 6 devices, MicroPython, also supporting PSoC 6, And then the XMC for Arduino, which are some specific Arduino ports that use all of the underlying drivers from Infineon, but allow you to take advantage of those inside of the Arduino IDE. And so we'll do some demonstration and talk a little bit more about those in the upcoming slides. So I want to do a little bit of some more details about Modus Toolbox. That one is the environment, the development environment kind of recommended by Infineon for many of these devices. It's kind of the professional path for product development. Modus Toolbox itself is designed to be a very modern, extensible development environment. And what I mean by extensible is it's able to use a variety of configurators, different underlying drivers and APIs to be able to target a wide range of devices, things like XMC devices, PSoC devices, going up to Treveo devices, USB devices. So it covers a wide range. It is provided as a collection of tools, libraries, and runtime, embedded runtime assets. So when we kind of talk about the word toolbox, you really kind of think of it as a toolbox. It's a collection of lots of different tools that allow you to create this development environment. And as I describe Modus Toolbox, I typically put these different components, these different aspects of Modus Toolbox into two categories. There are the development tools. So when you go to Infineon.com and you download Modus Toolbox, what you're downloading is an installer that's going to deploy or install these development tools onto your development machine, into your laptop or your computer. And this is going to have everything that you're going to need to be able to create applications, to be able to manage the software components that are inside of you wanted to use for your application, to configure the device itself, whether you're configuring the peripherals on the device or moving up and configuring the actual middleware or software that's on the device as well. And then in addition to all of this, you have what we would typically see in an embedded development is the IDE, the embedded development tools themselves, where you can do your compiling, programming, and debugging. Modus Toolbox comes with a couple of options there that we'll talk about on the next slide. The other side of it, right, so that was the tool side. The other side of it is all the runtime software. So these are primarily comprised of GitHub repositories. They come from Infineon or come from partners of ours. And the source code, the embedded source code itself is all hosted inside of these repositories. The tools are able to extract those, clone those directly from GitHub. So it's we're able to maintain those a lot more responsive. If there are any kind of bug fixes or new updates, those can get pushed independent of the tools themselves. And that also includes device support, new board support, additional application support. The kind of value of Modus Toolbox centers around really kind of four pillars. There's the development workflow itself, being a very flexible development environment. I can choose which IDE that I want to use. If I want to use an Eclipse IDE, VS Code, or IR, Kyle, have those capabilities to work out of the box. I can also do a lot just at a command line level. And that's really one of the things that I think sets Modus Toolbox apart, is that ability to work at a command line level and have the exact same workflow, the exact same output binaries, regardless of working at a command line where I'm integrating it into continuous integration, build systems, or just using the GUI IDE. Middleware management, and we'll kind of show this a little bit. There's specific tools, the library manager, that bring in various libraries, software. I can bring in an RTOS or bring in some type of a connectivity library and easily integrate those into my application. When I actually start my development, I've got a range of API levels. So I can program at a very low level if I need to be very efficient or have all of the knobs and dials for a particular peripheral. I can use those. I can use these low-level drivers. But if I'm working at a higher level, maybe I'm working with various connectivity stacks where it's a little bit further distance away from the hardware itself, I can use these hardware abstraction libraries. And that's going to make code that's very portable and easy to use across a range of devices, which really kind of feeds into the last column here, which is application portability. So a combination of those hardware abstraction layers, the code generators that will kind of abstract kind of the nuances of the hardware and allow me to develop at a higher level. The way that Modus Toolbox structures the board support packages and being able to kind of interchange those really makes some very portable application code. And the whole idea around Modus Toolbox is to provide a flexible development environment. So to allow you to develop the way you want to develop with a workflow that you get to define. I mentioned or kind of alluded to a little bit earlier about the different IDEs. So out of the box, it supports an Eclipse IDE with the ARM GCC. This is bundled with the Modus Toolbox installer. So when you download and install Modus Toolbox, it comes with an Eclipse IDE. You can also use the Microsoft Visual Studio Code, works out of the box, IAR embedded workbench, and ARM microcontroller development kit with the Microvision IDE. So all of those work. And then in addition to that, you then get a full command line interface. Under the hood of Modus Toolbox is a make-based build system. So you can leverage that with a full command line, build that into a scriptable environment, to use that into continuous integration, source code management. So a lot of really cool things for engineers that really want to get kind of down into the low level and try to automate and make that workflow as efficient as possible. When we get to the third-party ecosystems, so we'll go into kind of an overview of each one of these. So from a Zephyr Project perspective, maybe you're familiar with this, but oftentimes, a lot of these devices, if you're familiar with Linux or developing on Linux, especially on like a microprocessor or something like that, it's got kind of that feel to it, but it's a very lightweight implementation. They're kind of one of the taglines that they use is kind of fits where Linux is too big. But it has a built-in RTOS, a whole ecosystem around that, designed from the ground up to be portable, to be secure. Lots of connectivity options ranging from Bluetooth, Bluetooth 5.0, Bluetooth Low Energy, Wi-Fi, Ethernet, CAN bus, back behind several different IoT protocols, the CoAP, MQTT, USB. So a lot of capabilities. We'll talk about some of the specifics. So when we look at the support for the PSoC device itself, we'll talk about which of those connectivity options are currently supported. Certainly Infineon continues to support that and develop more features around the Zephyr project. But it's a very vibrant ecosystem with its own set of development tools, own set of applications, middlewares, libraries, tons of code examples, sample examples, and really designed to be a developer-friendly ecosystem with debugging capabilities, logging, tracing capabilities, and supported on Linux, Windows, and Mac as well. So from a MicroPython perspective, so if you're familiar with Python, right, many of us have seen that on using it in a desktop environment. MicroPython is an open source implementation of the Python interpreter that's designed to be very small and capable of running on these small embedded developments while trying to preserve as much Python functionality as possible. It's really set up to be a very simple programming language, excellent for beginners. Certainly as we're going through various kind of college courses and learning programming, Python is one of those ones that tend to be focused on in terms of learning how to code. Some of the notable capabilities: it's highly configurable, a very fast startup time, and has a built-in extensive test suite and code coverage just built into the capabilities. So as we release ports and capabilities, they're all tested. Lots of connectivity options. The ones we'll call out specifically for this is on the Wi-Fi connectivity, and then the various protocols, whether it's HTTP, XMPP, CoAP, MQTT, various libraries all supported inside of that ecosystem. When programming with it, you typically work in kind of two different ways. It's a scriptable programming language. You actually can have a serial prompt and use what's referred to as a REPL mode, where you really can type in line for line and actually see it, the code run as you enter it into the command line itself or enter it into the serial terminal itself. But it does feature host mode as well, or on target file system mode. So if I have a Python script that I want to load into the device, I can have it run that entire script, or even just actually flash it, actually store that Python script into the file system itself, and so that it just runs on boot up. And then the last one that we'll cover is the XMC for Arduino. So this is an integration of the XMC microcontrollers into the Arduino IDE, and it also supports platform IDE, which is, we won't get into that aspect of it, but that same enablement, the sites that we'll have links for in this presentation will have some more information. So if you prefer to use the platform IDE, you can do that. A pretty good list of supported microcontroller boards covering the XMC 1000 family and the 4000 family are built into this support. It's quite easy to set up. We'll walk through a little bit of that, but there's basically using the board manager built into the Arduino IDE. We can point to a specific repository and have access to these boards. And then once we're there, we can use the features and the capabilities that we are typically used to when developing and working with the Arduino IDE. It does work with Arduino IDE version 1.5 and newer. There are a few versions that have some caveats to that. So we recommend that you use the IDE version 2.0 or later. But you're really going to get those basic features that we see when working with the Arduino IDE and devices that are supported in an Arduino. There are some specific underlying features that are developed specifically for XMC, so things like the real-time clock, DMA capabilities, and the device control library, which is really what's interfacing with that device itself. As I mentioned, each one of these ecosystems is maybe going to have a slightly different characterization, a different level of support, what boards it supports, what drivers and libraries it supports. So we'll go through that to make sure that we just kind of understand kind of what we're getting into when we look at saying, oh, I would like to use, this PSoC 6 device with MicroPython. What does that really mean? Certainly from the perspective of Modus Toolbox, that's where we're going to see the most complete set of capabilities to support. This is the tool that Infineon is developing specifically for these devices. From device driver perspective, these are all aligned with the BSP, so the board support specification. The BSP itself is going to cover PSoC devices, XMC devices, USB power delivery controllers, AROC connectivity devices, both from the Wi-Fi perspective and the Bluetooth, the BLE perspective. And we're having more and more devices added to this kind of across the Infineon portfolio. The drivers, I mentioned this in the previous slide when talking about Modus Toolbox, but typically broken out into two different aspects. They're the low-level drivers. Typically, you'll see those referred to as the peripheral driver library. This is where I'm actually going to be able to control the fine-tune the control, have the most capability and flexibility over using a specific peripheral. So if there's a peripheral on PSoC or it's on XMC, I'll have full control over that. Hardware abstraction layer is available as well, and that's going to kind of provide a more common set of peripheral use cases, so a little bit higher level. And so I can take the same code running on a PSoC 6, and I can also run it on an XMC 7000, and that same code will work. Libraries themselves, we see a lot of different libraries. There are libraries that are doing human-machine interface. Primarily, this is the capacitive touch, which is one of the kind of key IPs that are available in devices like PSoC. Capabilities around, or libraries around graphics, connectivity, security, voice and audio. So a lot of kind of that ties closely into the machine learning, a lot of different type of voice capabilities around machine learning, Wi-Fi capabilities. And all these libraries are available. As I mentioned before, they are typically part of the GitHub repositories that are provided by Infineon and by our partners, but they're able to be managed very easily inside of the library manager. So you're able to pull those libraries into an application. There'll be a README, an integration README file. It makes it very easy to say, here's a couple of either parameters or tweaks that you have to make to integrate that library into your application. And a variety of code examples, reference designs all built on top of that. Just kind of a landscape overview of the third-party ecosystems and kind of what peripherals are supported, what middleware is available, and then the supported platforms themselves. So starting with the Zephyr column here, it supports the Bluetooth Low Energy. So there are specific libraries and capabilities around the BLE. It's available on the devices, the supported devices. In terms of the peripherals themselves, it supports the UART and GPIO. Other peripheral or other serial interfaces, other interfaces are in development, but the ones that are currently available today are UART and GPIO. Built on top of that, though, you get full access to the Zephyr middleware. So there's a large sample directory. We mentioned BLE, so I wanted to make sure we highlight, the Bluetooth, the Zephyr stack available in the Bluetooth Zephyr stack that's available. And other things like MCU boot, so you can do kind of OTA, various type of updates over the air. In terms of supported boards, there is a specific support for the CY8C proto board. This is the 0624343W. You'll see this board commonly shown across several different the ecosystems. It's the one that we'll do the hands-on demonstration on as well today. In addition to that board, there are a few other boards, both inside of the PSoC family as well as the XMC family that were developed by the Zephyr community as well. So those are available. I don't have specific details on what peripherals are supported. The details in this slide in terms of like BLE, UART, GPIO, those are specific to this CY8C proto board. On the MicroPython side, we have support for Wi-Fi. So in not BLE, but instead Wi-Fi, a little bit wider set of the actual serial and digital peripherals. We have support for SPI that was just released, support for I2C, PWMs, and GPIO control as well. Inside of the MicroPython environment itself, you're going to have access to the standard MicroPython libraries, a lot of those trying to align with as close as possible to Python. Specifically, we have the full MicroPython machine module that's really going to allow it to interface with the PSoC device that's supported. Networking capabilities, again, really aligned with the Wi-Fi connectivity piece. And there are various custom MicroPython libraries that are provided. I know one that's used quite a bit in some demonstrations focuses around using MQTT as well. Similar to Zephyr, the supported development board for MicroPython is the CY8C proto board, the 0624343W. And then the last one we'll cover on this slide is the Arduino ecosystem. So for the XMC-for-Arduino, we'll have full access for the digital, analog, and serial interfaces. We have drivers and capabilities around SPI, I2C, and I2S as well. The XMC-for-Arduino has been around quite a bit longer, so a lot more of capabilities in terms of the peripherals and the devices that are supported. There are several Infineon specific peripheral drivers. These are all kind of based on the underlying drivers, XMC lib that comes from Infineon, access to the standard Arduino libraries as well. And a couple of them that we threw out here as there were specific examples or tests for was around LED drivers, the one wire, the tones for driving out to kind of a PWM based signal, servo control, things like that. Several devices. We have the XMC 1100 XMC to go kit, the 1100 boot kit, 1300 boot kit. That's the one we'll be doing the demonstration on. And if you're working with the design challenge, the Connect Things design challenge, that's one of the ones that was included in several of the kits that were provided. The 1400 kit for Arduino, and then moving into the 4000 series, the 4200 platform to go kit, 4400 and 4700 relax kit as well. So a lot of devices and boards supported there. And so with that, we can get into, all right, how do I go use these? How do I actually go do something and kind of the getting started aspect of it? So from a Modus Toolbox perspective, and all of these slides, I have a QR code if you want to jump quickly to the link itself. We will also make this presentation available, and these are all hyperlinks that you can click on. From a Modus Toolbox perspective, there's a new tool referred to as the dashboard. This is kind of a central getting started utility. You can launch that. It'll kind of help guide you through getting started, getting an application created for the IDE that you want to use, access to kind of the key documentation. And you can bypass this as well. All this works kind of independent. You can jump right into those tools as you need to. But ultimately, you're getting inside of the IDE that you want to work with. There are library level configurators that you can use to configure things like machine learning, the CapSense configurator, Bluetooth. And as you need to make changes to kind of more fundamental pieces, right? Changes to how you're doing the pin setup or the clock setup, pieces like that. There are these lower level, these device level or BSP level configurators for configuring the device itself. Or for bringing in projects into libraries, bringing in middleware and other source code directly into the project itself. So we show a little bit of that. Let me minimize my presentation real quick, and we'll go through kind of a quick demo of this. We'll start out with pulling up, this is the dashboard itself. So the Modus Toolbox dashboard that you would use to kind of start things out. If you're new to Modus Toolbox, a good document to kind of walk through, get you details on how to get started, a link to the full catalog of documentation. So have access to all the documentation, training materials. These are actually kind of step-by-step training modules that will guide you through learning and understanding Modus Toolbox with lots of self-paced examples. We have videos as well, so you can watch the videos. Some of them are kind of high level, here's kind of, we'll talk about this feature, this capability of Modus Toolbox, but there are quite a few of them that go into, okay, let's go blink an LED, or let's go set up a interrupt handler, things like that. So you can watch through those. In terms of actually creating an application, first we'll select which IDE we want to work with. So you can even do with no, you just do things on the command line, the built-in Eclipse IDE, VS Code IR. So I'm gonna select VS Code, and it will dynamically update based on what I want it to do. There's a link for a document as well saying, okay, let's talk specifically about how to use VS Code for Modus Toolbox. But I can launch the project creator, and this will spawn an additional tool. Sorry, let me grab that. So this is going to go out and it's going to query the different GitHub repositories to be able to download various applications and supported boards. Once it does, you can see the full list of devices that are supported inside of Modus Toolbox. So the board that we've been talking about, or we'll do some of the demonstration on, is the 0624343W proto board. We hit next, and that'll then show the list of code examples or list of sample applications that we have. So ranging from Wi-Fi, sensing, peripherals are going to be kind of basic use cases of the different peripherals that are on the device, machine learning. So lots of different options to kind of get started, even just our basic hello world. And we can select that and have it create an application specifically for Microsoft VS Code. And I actually have that already set up. So I've got another project here. So we have let's minimize these. I've got VS Code up and running. I've already opened up a project. So this is just done by file, open, workspace from file, go to wherever that project creator had created the files, and we have our application. And I do have I have a board connected. So with that, we can go in, we can build our application. So terminal build, and these are all detailed in working in the guide for working with VS Code. And we've got various other abilities to debug. I'll probably mention this real quickly. There are some specific extensions that were added to make a lot of this capability possible. So specifically the Cortex debug. This is all detailed in the guides, the documentation for Modus Toolbox. But I can debug this application, right? So I've got abilities to launch, attach, erase, debug. So we can actually go ahead and launch a debug session for this particular board. This is a basic hello world example. We'll have a terminal as well that we can show the output to. And I've got some breakpoints set up as well. So if we scroll down, we're going to get some various kind of hello world capabilities, and then I've got a breakpoint set up here. And so we'll just wait for that to flash. There it goes. Clear that. Okay, so then I've got my hello world up here. Oh, wait, no. It hit my breakpoint here, so it's there. Now it's hit my breakpoint. Let me clear this real quick. So fresh terminal. So we're here at our breakpoint, and as you'd expect, right, we get our typical debugging. If you've used an IDE before, we're in a debug session. I can step through this code. I can step into and out of functions. I can also just hit resume, and this will run the application. I have the breakpoint set up, so after I hit enter not once, that'll cause, I don't have a camera set up, but it's blinking the board on my, blinking the LED on my board. And if I hit this again, then I hit my initial breakpoint. So if you've used IDEs before, if you've done debugging environment like this, you see kind of the typical behaviors. We can look at various variables that we have. We can go in and look at the peripherals and the different memory regions that we're interested in. Again, step over this or resume the application. So we'll terminate this debug session. And that's kind of really it in terms of getting started with Modus Toolbox itself. For downloading Modus Toolbox, this is where the QR code will take you. You can access the installation guide, download the application itself. I would recommend looking through the installation guide, make sure you get it set up properly, especially strongly encourage you to use the default settings when installing it. If you do deviate from those, make sure to pay close attention to the installation guide to handle any kind of issues or pitfalls that you may encounter with that. Once we have a project, right, so let me go back to my VS Code. If I wanted to modify this, I've already got it open. I've got the library manager open. And this is pointed to that same application folder. So this is where I had created this application. But I can come in, I can see the various libraries that I currently have included. There's not a lot in here, so it's just a really basic example, but I can add additional libraries. So I can select the add libraries option here. And I can bring in different, I want to bring in a connectivity option, or maybe I want to bring in FreeRTOS, various other middlewares. So a lot of stuff here. You can search through this as well. As you highlight one of them, you can get more details about that particular middleware. Check mark next to it, hit OK, and that'll bring it in. If there are any dependencies as well, it'll resolve any dependencies that may be included in this. You can also handle version control. So this is by default going to bring in the latest version, but if I know I need to use an older version or want to recreate a specific use case, I have complete control over versions. If you do select if there is an update version, you'll actually see a little icon here saying, hey, there's a new version of this, and you can go check it out, check out the release notes, find out if it's going to meet the needs for what you need to update. And you can update that, and it'll pull in all of those different details into your application. All right, so with that, let me go back to my presentation real quick. And we'll talk about Zephyr. So in terms of getting started with Zephyr, there are two main documents or resources that we'll point you to. First is the getting started document on the Zephyr project, the main project itself. So these are the same instructions that you would follow for any development kit you're getting set up and running with Zephyr. It's going to include two primary steps. You're going to install Zephyr itself and install the dependencies, like things like CMake, Python, a GCC compiler. Then you'll install and set up the actual Zephyr SDK. There's a one-time script that you'll run every time you update to a new SDK. So we'll run that. So that kind of gives us that base installation of Zephyr itself. And then we can go into some of the specifics around working with the board itself. So there's a specific CY8C proto kit supported boards document, and you'll follow that to complete the steps. So there are some specific Infineon binary libraries, so things related to the BLE firmware, images that run on the Cortex-M0, the hardware abstraction, the HAL itself. You'll also need to download OpenOCD. This is what's going to allow the Zephyr build system to actually then communicate and flash the board. And then once we have those kind of credential or those prerequisites set up, the details set up for the Zephyr board itself, then we can use the West build tools to compile our application and to flash our application itself. So let's switch over to that, and we'll kind of show those pieces. So the first thing we'll do is let's kind of walk through the actual documentation. Let me pull that up. So we've got the Zephyr project. I just went to the homepage, Zephyr project. We can go to the technical resources documentation. And from this page, there's several different things that are probably interesting, right? We're going to look specifically at the getting started guide, but we have access to the samples and demos that are available, the supported boards that are available as well. So let's, we're not going to walk through this entirely. This is it does take a bit of time to go through this entire process to get it set up, but there are detailed instructions, whether you're running this on a Linux, Mac, or Windows. We can run through the actual setup of Zephyr and the dependencies, to actually installing the Zephyr SDK. And then we can go into the actual board support package, which give me just a second, I've got a link here. So on the supported board page, and you can find that by looking for the supported boards. It's also links to it in the presentation. But on the board itself, we're going to complete that installation process. So we'll scroll down. It's got a lot of details about how to use it. The various peripherals and capabilities are supported on this device. And then the steps that we need to complete now to get this board up and running. So these are where we're going to install those additional Infineon libraries. And then we can actually then go in and build our application. So I've got a board that's already connected. So let me switch over to my terminal window here. So I'm actually doing this through my Linux box. So I'm shelled in to my Linux machine, and I'm already inside of my Zephyr project. So I've done all those steps to download everything. I can go into my Zephyr project itself, and then we've got some commands already set up for us. So I'll make some small tweaks to the Hello World application, and we'll just compile that and build that. So we'll open that out, and we've got kind of our basic Hello World, and we can come in and do things like another, oops, if I can type. So just a simple change so we can see that working. We'll save that. And we can go ahead and build this application. So the commands that we use, and I have reference to those in the presentation, but we'll do a West build, specify that we want to use the CY8C proto board, and that we're doing this directly off of the samples Hello World application. So we can go through and we'll build that application, and then we can do the programming itself. So this is where we're using that OpenOCD. So we downloaded a specific version of OpenOCD. This part of the instructions that are documented that are needed to be able to flash our board itself. So we'll flash it to our application, and then we can see over here on the using Minicom in a separate window, we see the Hello World, and then we got our welcome to this webinar. So that's really it in terms of kind of getting started with Zephyr. There are a variety of different sample applications that you can use. Make sure. So we can see runs from kind of basic Bluetooth drivers, and as we mentioned just before, if we go back to that kind of landing page, we can see more details about these samples and demos. So a lot of resources to kind of get up and running with Zephyr there. But once you do get it up and running, very easy. It's all command line based in terms of running the West build system, but quite easy to be able to build those, very fast to compile, and then we can go on to actually building the application. All right, so now let's see what's jump back to the presentation. So let's go through MicroPython next. So we'll actually go through kind of the whole process here, or at least a little bit more of the process. This is pretty quick. So in terms of getting started with MicroPython and PSoC 6, so there is a specific MicroPython fork that is available that has the port or the capabilities of the support for the PSoC 6 device. You can find that at the link here. So again, the QR code will take you here. I also have the URLs down here. And then once you get a copy of the presentation, you can use those. Our steps are going to be, first we need to download MicroPython into our device itself. So there is an image that's already prepared for this particular board, and we flash that image using the programming tools onto the PSoC 6 device. So once it's there, once it's on the device, that device is now running this MicroPython interpreter, and we have access to the terminal itself, so we can start typing in our Python commands, or we can use tools like the Arduino Labs IDE. There's several other IDEs that are supported to be able to write out entire scripts and to be able to flash scripts to the board itself. So we'll go through these steps. So, and I'm going to go through all these. I'll actually install MicroPython into the device, and then we'll open up the IDE that kind of comes baked into the getting started script. You'll kind of understand how that works here in a second. So let's say close this. So I'm back on my Windows machine. So I am just have a PowerShell, a Windows PowerShell open up. Command works as well. The steps for doing this, I forgot we wanted to show those. Let me open this up. All right, so we'll go to the MicroPython page. This is the specific fork that's available for MicroPython. And there are details inside this getting started section. So there's online documentation. So this would be where to go. Click on the online documentation, and this will guide us through what are the steps for getting our PSoC 6. So let's see a quick reference for the PSoC 6 and installing MicroPython. So that's kind of the different links that you would use to go through this. Directions for doing this on Linux or on Windows, but really there is a script, a simple command script that we download, and then we're able to execute that script, and that has even a quick start mode that really just takes care of everything for you. So that's what we'll show here. I have already downloaded the script itself. So if we look inside of this directory, I've got this py or mpy PSoC 6 command. And if we just hit enter, it'll show us the various options that it has. So kind of like the help. It's got parameters doing the quick start. I can do device setup, deploy the firmware itself, or erase the device. And we're going to do the quick start option. This is going to go through, it's going to download any additional pieces that we need. So it's going to download the OpenOCD binary. So this allows it to program MicroPython into the device. So this takes, a couple of seconds to go through. Once the MicroPython is flashed to the board, then we can look at it in a terminal. It'll look just like a device itself. It'll look just, we'll see the actual MicroPython command prompt, and we can enter in commands there. So I think with running the webinar, the download's a little bit slower than it's been in the past. But all right, so it's downloaded all the tools that it needs to, the actual hex file. It's letting me know, hey, make sure the board's connected. This is the same board that we had used previously with VS Code. So we'll just hit enter, and it will flash the MicroPython application to the board itself. So you actually see over here in the terminal window that things are getting erased. So the lines are just floating. We're getting some noise in the console. Let that program. All right. So at this point, and let's see, reset this, make sure that it's clean. Okay, so at this point we can see I still have that same serial terminal open, and it's got the MicroPython interpreter. So you can see I can actually type in commands like help, actually see some different capabilities, right? How I would configure pins or different things like that. What I'm going to do though is I'm going to close this terminal, because what I want to finish the demo out is using the Arduino IDE, or the Arduino Labs IDE, which the script hasn't finished yet, right? It's still waiting for us to press any key. We're pressing a key and it's actually going to then install and open up Arduino Labs for MicroPython. So this is another little IDE. There are other ones documented on that page that you can use as well, but this one just starts automatically as part of this quick start script. So we'll show it. So that popped open here. So a little simple IDE, we can connect to our board, COM5 as well. And we'll see that same, we've got the terminal window down below. We've got scripts that we can run up above as well. If we can do the same thing, right? I can do things like type in the help, type in, print hello world, and see it behave in kind of that REPL functionality. I can run these scripts. So this is just a real simple script. It's just going to print out a series of 10 dots with a 1/10 of a second delay in between. So I can run that script and see that output on the screen as well. There are several examples. We can even tweak it. I've got some code here we can throw in here. Not doing anything too interesting, just because we don't have a camera on the board, so we're just doing things that we can see the output. But we'll get another little thank you for attending this webinar output. So we can see that got that small little tweak to it. You can also go into the files themselves and to be able to download applications. So this is an application that I downloaded from the Hackster.io project space. So I've got a link to that in the presentation as well. There's several different starting applications that are available on Hackster.io for working with MicroPython and Arduino as well. So, but that's it. There's other IDEs that you can use, but that's kind of a basic startup of working with MicroPython itself and the PSoC 6. So our last one, let's return back to our presentation. And the last one we'll talk about is then the XMC for Arduino. So the prerequisites for this, and these are all captured inside of the associated page itself. But we're going to download the Arduino IDE. This other way. We'll download the Arduino IDE itself. There, inside of it is a board manager where we'll walk through the steps of adding in support for the Infineon XMC microcontrollers. This does utilize Segra J-Link, so there is a prerequisite to install the Segra J-Link programming tools. And then just you're into the development. You're into the typical environment that we would see for Arduino, where I can use the IDE, create the scripts that I want to, and then to be able to generate hex file and program those directly into the board. So in terms of the hands-on, this is the page that we'd be taken to. It's got all of the steps for getting things started, right? For downloading the Segra J-Link and the IDE. And let me open up the IDE. And we'll show some of that here in just a second. Should be opening up here. There it goes. So following the details inside of that web page, right? So the details in terms of the prerequisites and the setup, what it's going to guide you through is to going in and underneath preferences, to being able to specify an additional URL for the board manager. So we can see that I've already got that URL pasted in. And what that's going to allow is if I go to the board manager itself, and I filter on Infineon, We can see that there are a couple of different options that are available. I have the version 2.x, in fact, it's the 2.2 installed, and you see the list of development kits that are supported by that. There is an older version of 1.7 that's got some additional, some older boards in it. So based on what board you're using, you can install the correct board support package. With that in, and let me, I'm going to disconnect the PSoC board from my computer and plug in my XMC board. I can now select that I've got a board here. This is the XMC 1300 boot kit. And so now I have access to, or I'm connected to the board itself. And then we have our typical Arduino environment. We can go in and use some of the examples, the built-in examples. There are some specific XMC examples as well. I've got some code that I already prepared. It's basically the analog sample project, so the sample sketch, that the built-in sketch, but I made some tweaks to make sure I was using the right ports. But I've got that board connected, and I can go ahead and run this. So we'll just upload it to our device. And this is just going to basically in a loop read the potentiometer. There is a potentiometer on this board, which kind of makes this a little bit more of an interesting demo. And we can run that potentiometer. So let's open up the serial plotter. Everything keeps opening up in the other screen, the serial monitor. So we actually see these, and we'll turn the accelerometer, and we actually see that up and down as we adjust the potentiometer on the board here. So quite easy to get set up, right? It's just really a matter of bringing in the correct board support inside of the board manager. And then after that, it's a kind of your typical environment that you would use for the Arduino IDE, working with the built-in examples, working with some of the specific examples provided for the XMC device itself. All right, we don't worry about saving that. And we'll jump back to the presentation. I know we're getting a little bit short on time, so we'll try to get through the rest of it. So this webinar is being done in conjunction, or kind of in alignment with the Connect Things with Code. So if you're not involved with that, just make sure you're aware of it. There is a contest. Submissions are open now for proposing or submitting your projects and your ideas until October 3rd. And then we'll do kind of announcement of winners, and you can win prizes and all kinds of cool things by the 13th. A little bit of details about this. One of the things that we're really trying to encourage participants to do is really to be able to connect something to the microcontroller itself, right? To wire something up. If you've got some kind of crazy simulator or other type of device wired into the board, and create a library. We want to try to really facilitate a community where people can then go in and they can take that kind of driver that you created for this cool little sensor, this little accelerometer or CO2 sensor, and be able to go reuse that in a different project. So that's kind of one of the driving factors behind the contest. So keep that in mind, and it's highlighted here, right? We want to create device drivers that can be publicly reused. All right, final comments, and then we can open it up for a few minutes of Q&A, and certainly we can follow up as needed with any additional questions. I've got a variety of links. These are all captured from the presentation below. Also a QR code for the design challenge itself, as well as the Infineon project space on Hackster.io. So great resource to go in and find projects specifically around the Arduino and the MicroPython projects. So some cool projects there. And with that, Katie, we'll open it up for Q&A in our last few minutes. All right.
Awesome. Yeah, we have a lot of questions that have come in, which is great. Well, if there is a way that we can follow up with some of these folks, or at least give them a resource for where they can ask these questions if they don't get their questions answered, we will be sending out an email follow-up, so we can include that information on there and on how to get those questions answered if yours doesn't get asked during today's session. So First one, can we use Modus Toolbox for other than Infineon products?
So the build system itself is really built around the Infineon project. So when we look at things like the different BSPs and the build environment, those really are set up to work with Infineon projects itself. So it's for Infineon products.
Right. What is the recommended development OS for Zephyr? Can we use Windows?
Yeah, so both Windows and so with Zephyr, I'm trying to make sure I don't mix too many up, but with Zephyr, it's Windows, Linux, and Mac that are all worked. In the demonstration I showed Linux. Just to me, Zephyr kind of is in the realm of a Linux kind of mindset anyway. So I did the development there, but it works well in Windows as well. And just follow the specific instructions. So if let me go back to the page itself on the getting started, it will guide you through the specific steps for setting it up in Linux, Mac, and in Windows itself. So just follow those instructions closely to get it set up. Great.
Okay, the support of XMC microcontrollers is available for Arduino IDE 2.x or also for 1.x version.
Yeah, it starts with 1.5 is the earliest version that is supported. More details are on that specific page. I believe there's one caveat related to the 1.8 IDE that may cause issues. I think there's maybe a workaround identified on the page. So just pay attention to that. I think there's potential issue with 1.8, but anything 1.5 and newer should work.
All right, great. Is there support for MicroPython on the CY8C kit -062S2 43012?
Yeah, there's a lot of alphabet soup there. What we can do is we can go and look at there is a supported boards page. And let's just go directly to that page as well. So some of these are community supports. Some of them have been contributed by Infineon, but there's support for the PSoC 6.3 BLE Pioneer module, PSoC 6 Wi-Fi Bluetooth Pioneer kit, the CY8C Proto, that was the one that we showed today, and then the CY8C Proto 6.3 BLE. And then I think there's also
Hey, Clark, I'm sorry to interrupt. The question was actually support for MicroPython on that.
MicroPython. Oh, I apologize. Yep, I maybe misunderstood that. So currently today, the MicroPython is only supporting the CY8C Proto 062. I know that the team working on this has plans to create additional devices, but what's available today is just the that one proto kit. Yep. Thank you, Megan, for catching that.
Yeah, thanks. Great. I think there was a question about whether other sensors could be used apart from the bundles that are part of that contest.
Yeah,
so.
Absolutely. In fact, I would encourage that, right? Because like I said, one of the things that we're trying to do is really develop a community of drivers. And if everybody's just developing the same driver for the same sensors, it's kind of less interesting to the community. So I would love to see as many just different sensors and different things brought into the Connect Things contest. That's my personal kind of bias towards it is I want to see just sky's the limit, right? Bring in all kinds of stuff.
Awesome. We've got one more minute. Let's go with this one. Not sure if my question went through, so asking again, are there any tutorials or guides for how to integrate Modus Toolbox, the files it creates, and Zephyr in an IDE, so VS Code, for example?
So in terms, so make sure I'll answer it, and hopefully I'm answering it correctly. In terms of Modus Toolbox, so when we're working with Modus Toolbox, support for the built-in Eclipse IDE out of the box, support for VS Code out of the box, IR and Kyle as well. There are specific documents, and if I go back to the dashboard for Modus Toolbox, all of these are inside of the documents link as well, so you can click on the document link. But specifically, when I selected that I wanted to use the VS Code, it provided me a link directly here. And this link, it's opening up in my PDF viewers. Give me just a second. this is going to walk you through the exact steps in working with, creating projects for, and opening them up inside of VS Code. So it works out of the box. There's really nothing else that needs to be done other than from an installation. There were those extensions that need to be added. So there is a Cortex debug extension that I have, and then a C++ extension. All of that are detailed in the installation guide for Modus Toolbox. Now, when it comes to some of these other ecosystems, right? So if I'm trying to tie in like a Zephyr build system or things like that, outside of my awareness, I would check with those community spaces to see if they have anything that leverages some type of an IDE, but I can only speak specifically for the Modus Toolbox.
Awesome. Great. Well, we are out of time. We had a lot of other questions we didn't get to, and we apologize, but we will try to get some answers to you and some resources for you to go and ask some more questions if you didn't get your question answered during today's webinar. We'll be sending out a follow-up email in the next couple of days. Thanks for joining us, and thanks, Clark, for this presentation. This was great.
Yeah, and thank you again, everybody, for joining, and we'll get as many questions answered as we can.
Yeah. Have a great rest of your day, everyone.
Yeah, thank you.
Bye.